The goal of this project was to create a drone blade through additive manufacturing that, with the full system, will be fully capable of lifting 400 plus pounds safely while traveling 60 miles per hour horizontally. One blade will be modeled, and if this blade could reach the required thrust force, then the drone would be capable of lifting the payload.
Brief calculations were performed to determine what the estimated flight time and amount of drone arms required would be. This was done by taking a factor of safety of 2 into account, which resulted in a flight time of roughly 8 minutes and 8 to 10 drone blade arms.
The first blade design was a simpler design that was iterated on by adjusting the widths and angles, which then had countless hours of CFD analysis performed on them to determine what combination may produce the largest amount of thrust.
The initial blade design did not use any standard airfoils and was not compatible with this high thrust application. That is what led us to our final design, which also had several iterations involved. This used 3 separate standardized airfoils to optimize thrust while maintaining efficiency.
This blade was then iterated on, changing the widths, lengths, and angles to match those from the earlier simulations until the thrust and torque values were close to the requirements. Further iterations were designed with improvements of the tip, base, and trailing edge of the blade to reduce the overall drag it was experiencing.
At last, the final design was obtained. This design showed the strongest CFD results in all aspects. The blade was printed by the CBAM25 carbon fiber 3D printer in the Brinkman lab at RIT. The CFD and FEA results were to be proved by experiments performed on the blade. The blade was to undergo a thrust, bend, and torsion test. All of these tests will provide results that can be compared with those shown in the CFD and FEA analysis.
To see what the application of this drone will be, the data that went into designing it, how the printed out blade performed in the physical tests, and whether or not we succeeded in meeting our design goals, you will have to come see us at our booth at Imagine RIT.